Find out the middle node of the linked list. The middle node of the linked list is always going to be the mid plus one. So whatever, for example, here total nodes are 5, so that the middle node is going to be 3. If total nodes are 6, the middle node is going to be 4. So what he is trying to say is, if the total node count is even, then return the second middle node. If the total node count is odd, you can blindly return the middle node. So how do you solve it? Do you understand the problem statement? Yeah, so how do you solve it? So this is what he is trying to say. Let's come up with brute force, and we'll see what are the possible solutions we could make. So we have 1, 2, 3, 4 and 5. So actually here the total node count is 5, so that middle node is going to be the 3. And similarly he was given, if it is even, so the middle node is going to be the second middle node. So 5, 6, the middle node is going to be there are two middle nodes here, so but he is asking us to return second middle node, which is 4. Now what did you understand here? What did you understand? So first, can you tell me what, irrespective of even or odd, which value is going to be the middle node?
3.
Length by 2 plus.
Yes. So whatever length you have, length by 2 plus 1. So which is going to be the resultant node, right? So they are expecting. So for example, here the length is 5. So 5 by 2. So which is 2 plus 1. So which is you get 3. And here also length is 6. So 6 by 2, which is 3 plus 1. So which is 4. So the fourth node is going to be the expected answer. Now how do you solve it? What is a brute?
Fine.
We can maintain two pointers.
Okay, if you maintain 2 pointer, how do you know that? How do you know the middle node? Forget about 2
Move one
pointer.
step,
For example,
the
if
other
you
one 2 steps.
yeah, so forget about 2 pointer. If you want to solve with single pointer, how do you solve it? So first I will find the length, right?
Yes.
So first I will find the length. So length is going to be n. In second iteration, I will also know what is going to be the middle node, correct? I'll also know what is going to be the middle node based on this n by 2 plus 1. I'll go to that counter node and return that node, correct?
Correct.
So it's a simple brute force approach. So what is the time complexity here?
Log n.
Log n. How it is log n?
2n.
First you will find the length, right? So to find the length, it is going to be linear. Plus you will find the middle node, right? So to find the middle node, it is going to be n by 2. So obviously which is going to be n, correct? Correct?
Yes.
So what is the space complexity here?
Constant, as we are not
So
constant.
Yeah, so it is constant. Okay. Let's do it quickly. So simply what we can do, so initially you will maintain counter as 0, and you will start list node current is equal head. So as long as your current not equal to null, then you will increment the counter for this current node and move the current node to the next node. So you will get a counter, you will get a value. Now you will have a made, which is going to be counter by 2 plus 1. Now what is our job? So again we will initialize counter as 0, and Yeah, so we will just move again, we will initialize the current to head, and we'll just move our counter less than mid, because you are already not less than or equal to, because you are already holding the head into current, so that you can understand. So you can have counter plus plus and current equal to current dot next. So finally return this current. Clear? Logic is clear? Clear? Okay. I think what is expected, so we are expecting 3, it went up to 4. Okay, so ideally you should start from 1, so it will work. So because the reason, because you are already considering current as 1, so you are already considering current node, so that which is 1, so you just move on. So it's a matter of identifying that iteration, so it works out. Is this clear, Ajay, Maithili? Yeah.
That counter one I don't understand.
This counter one,
Okay.
right?
Is it because you're counting the first? It's not from zero based index, right? One and
Yeah, yeah. It doesn't matter. It's a math formula. That's it. So
okay.
why I started from 1 means I already have a head node, right? Head is current, right? So I should consider this as 1. Then when I move to the next, so which is going to be 2. You
Okay.
understand?
Yeah, go.
Yeah. Yeah, then what is the so this is fine, which is also be we are able to solve this problem in linear time. So can you come up with optimistic solution? Can you can you solve this problem in linear time? So we have done two pass. Once we find out the length, in the second iteration we figure out the mid value. Can we come up with a single pass solution rather two pass? So this is one and this is second, right? Can we come up with a single pass solution? You have 1, 2, 3, 4, and 5, right? We need to find out a mid value. So, do you get any idea? If I use 2 pointer, can I able to get
Yeah.
the mid?
Yes, we
How?
can get easy.
How?
So one will go one step and the second pointer will go two steps.
Okay. Yeah.
By the time the first pointer
When
reaches the end,
second pointer is the end,
slow is in the middle.
first pointer will be in the middle, right?
Yeah,
Situation.
that's it, right? So generally, let's say two people are running. So two people are running. Okay, so one is slow, one is fast. If fast is taking two jumps at a time and slow is taking one jump at a time, then by that time, so let's say two jump and one jump at a time. So uh, let's take each one done 5 iterations. So it means 1 into 5, and it means this is 2 into 5. So here it is 5, here in this case it is 10. What did you understand here? For example, if the length of the array is 10, by the time this fast pointer reaching 10, the slow pointer reaching 5th position. Correct? Correct, na? Because the fast pointer is taking two jumps, the slow pointer is taking one jump at a time. So that if there are 5 iterations, so assume you did 5 iterations. If you did 5 iterations, by the time the fast pointer reaching 10th position, the slow pointer is into 5th position. Is that correct? Did you understand this?
Yes.
Mathematics, don't
See,
worry about, don't compare this value with the current input. I'm just telling you the concept. So by the time, for when fast pointer moving 2x times, so slow pointer will move x times, right? because fast is taking 2 gems, slow is taking only 1 gem. So if you speak technically, so when a slow pointer taking x steps, by then fast pointer takes 2x steps, right? Yes or no? Is that clear, Ajay?
Yes, Shreenu.
So let me explain the iteration here. So what I do, so this is my slow, this is my fast. So what I do, I'll take one iteration. So in one iteration, slow pointer will take only one step, but the fast pointer will take 2 steps. So in this case, fast will be here. Now again in the second iteration, slow pointer will take one step and fast pointer will take 2 steps. So from here, the fast pointer is reaching here and slow pointer reaching here. So initially, slow is taking one step, fast is taking 2 steps. So now you see here, the fast is reaching already end, so that the slow is pointing to the mid value. So you can simply return slow pointer value. Understood? Maithili, understood?
Yes.
Yeah.
So, for example, yeah, so let me write a code for this. So you are going to have 2 pointers. So one is slow, which is also starting at head. Another one is fast, which is also starting at head. So we will make sure that as long as your fast is not equal to null and fast dot next is not equal to null, so we will just take one jump for the slow pointer and 2 jumps for the fast pointer. So fast dot next. That's it. So finally you will just return slow pointer. That's it. So it always points to the mid position. Clear? So what did you understand? You feel like linked list programs are more or logical, right? Those are not conceptual. Correct? You don't feel the fun of recursion or DP on other data structures because those are very interactive. Here you need to apply a little brain to solve the problems. So let's move on to the next problem. Merge two sorted lists. So the problem statement says, this is our problem statement. 1 2 4 1 3 4. Okay. 1 2 4 and 1 3 4. So you will be given two sorted lists. So this is list 1 and this is list 2. We just need to sort this. We just need to merge these two lists, both the list, and at the end the merged list should be in sorted order. So how it should be? So it should be in sorted order. So the resultant list should be something like this. 4 and 4. So this is the expected result. So how do you solve it? How do you solve it?
Traverse to two lists at a time and then check whether which is greater or not, greater than or equal. If it's equal, just add it.
To whom we need to add?
I mean, the starting one, whichever is minimal.
Okay, so one brute force approach is one of the brute force approaches. You will take an empty node. Okay, so you will take empty node. So first what I do, I will compare L1 value less than or equal to first current L1 here, current L2 here. L1 dot next L1 dot value less than or equal to L2 dot value, so that I will add here. then I will move L1. So there is no change in L2. So now if you closely see, this is my L1 and this is my L2, and if you see L2 value is less than L1, so that I'll add L2 value here, then I'll move L2 here. Now L1 is here, L2 is here, so 2 is less than 3, so that first I will add L1 value, then I will move L1 to here. Now let's move on. Now this is L2 value and this is L1 value, so 3 less than 4, so that I'll add L2 value, so which is 3, then I'll move L2. Now if you closely see, both are equal, so that I can add L1 value, so which is 4, I will move L1 further, so that L1 is null, so that whatever left over L2 I will just append here. Then finally, so this list I will just return. So this is a brute force. Hope you understood, right? Or did I went little quick? Maithili, did you understand?
Yeah, understood.
Okay. Now, how do you do that, right? So how do you do that? Okay, so let me write a brute force code, then we will try to optimize it. So what I will do, I'll just take a dummy node, list node. So this is empty node, I talked about it, right? So I'll just consider it as a dummy node. Okay, nice. So what I'll do, so this is my list node current, which is going to be the dummy, and so that I can directly return that. Yeah, so let's move on. So I will just move L1 not equal to null and list 2 also not equal to null. So what I will do, so I'll check if list 1 dot value less than or equal to list 2 dot value, then it's time to I'll just make sure that my current dot next is going to be new node of list 1 dot value. Then I will just make sure that I'll move the list 1 to next node, so that I will just say list 1 equal list 1 dot next, and otherwise what I'll do, I'll just do the reverse. So current dot next is going to be list 2 dot value, and list 2 equal list 2 dot next, and for each time I'll just make it current equal current dot next. So if you closely see, I started from dummy node, and this current node is keep on adding all the list 1 list 2 values at the end. So at the end, one of the list can be null. So what I can do at the end, current dot next equal, if list 1 is equal to null, I will add list 2 leftover values, otherwise list 1 leftover values, so whatever it is. And finally, this current is pointing to the last node, right? But head is present at dummy dot next, right? So because dummy is the current, and dummy dot next is going to be either it is list 1 or list 2, whatever it is. So you can simply return dummy dot next. Is this logic clear, buddy? Is this logic clear? Akash? So it is a
Yeah.
new list. It needs lot of practice. Uh, if you practice, you can write faster. So what is the time complexity here? What is the time complexity? So can you think and tell me what is the time complexity?
We have two lists, two linked lists. It's n only, right? We are not looping one in another.
What are you defining m? What is m here?
I mean, the
Length of the
length is
shortest
high,
list.
I think we can go by the
Length of which list?
Then shortest linked list.
How do you think that? So can you think little more? Okay. Generally that is a common confusion we get into that. How do you know
Length of
that it is
two,
always going to be shortest list length?
because we always traverse until the shortest one is done, and for the remaining one we just append it.
Let's say this is how it is. The list is 1, 3, 4, and 2, 2, 4, and 6. Then how many times do you traverse? So what will happen here? Can you tell me? So this is my dummy node. First you will append 1, right? So first you are here and you are here.
Yes.
Then in the second iteration you will go here, then you will append 2. The third iteration you will append 3, correct? In the fourth
Yeah.
iteration this is here, and in the fourth iteration you will append 4, and here in the fifth iteration you will append 5. In the sixth iteration you will append 6, correct?
Yes.
So as per your logic it should be 3, right? But in this case it is happening 6 iterations, right?
Yeah, it's double of that number.
Yeah, what does it mean? Double of that number means. So let's say length of this list 1 is m and length of this list 2 is n. So which is going to be m plus n, right? Correct?
Yes.
Clear, my
But what if the second one is much longer, like 3, 4, 6, then 8,
doesn't
10,
matter.
12 is there?
Yeah, that doesn't matter. So you are saying big O of 2m, correct?
2m, yes.
Yeah, 2m plus, yes, that's correct, man.
Yeah. Because of the second one, we are anyways not going to traverse till the end.
No, that is wrong, right? Let's consider worst case. So your case will be valid when all are ones, and this is just 2, 2, 4, 6. But this is the worst case, right? When all numbers are unique, you are making 6 traversals, right?
Let's say there is only one node in the first list, and in
No,
the second one we have got 10 nodes.
when you are speaking about time complexity, right? Don't get into optimistic case. You should always think
Yeah,
about the worst case. So this is the worst case, right? 1, 2, 3, 4, 5, 6. So which is going to take 6 iterations, right?
Yeah, right.
Which
Correct.
is going to take 6 iterations. So definitely it is m plus n. So what I thought is, if somewhat it is, there are another 100 nodes here. Generally it is going to be big O of 2m, whichever is minimal. But you can, in order to avoid the confusion, it should be m plus n. Clear? Clear, Ajay? Okay, so what is the mistake we are doing? What is the space complexity here? Can you think and tell me what is the space complexity?
Order m plus n.
Yes, order of m plus n. Why? Because for every value present in list 1, for every value present in list 2, we are creating a new node, no? Yes or no? So at the end, my new list is going to be order of m plus n, right? Correct? Yash, Kalyan, Maithili, Akash.
Yes. We need to create a new node every time.
Yeah, that's where we need improvement, right? We need improvement. So we don't need to create a new node, right? So we can simply append. Maithili, are you clear?
Yeah, Srinu, I'm trying to understand.
Yeah, so what are we doing here? So for every node, so this current is going to have all the m plus 1 nodes, right? M plus n nodes, right? This current is scanning through all the m plus n nodes, right? in worst case?
Yeah.
Correct. This is what happened, right? So you have one. So you have one, two, three, and let's say again one, two, three. So how it works? So first you will add, this is my current, first you will add this node value 1, then you will add this node value, then you will add this node value, then you will add this node value, and this node value, and this node value. So it means my new generated list is containing total, these are m nodes, these are n nodes. Let's say we have total m plus n nodes. So we have total m plus n nodes, correct? Is that clear?
Yes.
Maithili, your voice is not audible. Okay. Okay, so total we have m plus n nodes. Then for each node we are creating a new list node, right? So it means for each node we are creating a new object. So definitely which is going to be m plus n. So in order to avoid that, so do we really need to do that? So can we make it as list 1? And can we make this as list 2? Will this work? Will this work?
Yeah, it will work.
How? If it works, why it is working?
We are already checking right there.
Which point is, which line number is making sure that the latest added lines can able to work? So let me run it.
Should work.
Yeah, it is working, but what is the line number is crucial here. You are adding complete list, still it is working, and which line number is making sure that it is valid?
The value comparison lines.
No, that is not.
No, the number 20, and we are going ahead, right? Each time when we take.
Yeah, but we are adding here, right? We are adding previous node, and we are moving on to the next node. But still
again,
it is working.
The whole list we are adding. Okay.
Yeah, so still it is working. So which line number is critical here?
Current equal to current, that
Yeah, so this is what doing the job, right? So let me explain it.
we are moving the current.
Yeah, so we are moving the current, right? So that's why it is able to handle all the edge cases. So let's say this is what we have. We have 1, 2, let's take 1, 3 and 5, and we have 2, 4 and 6. So this is L1, this is L2. Okay, so let's closely understand. This is my current. So current which is initially empty. So closely understand. So current is pointing to L1 now. So which is 1. So it means 1 means it is pointing to whole the list. Okay, which is pointing to whole list. So L1 is here, L2 is here. Now you increment the L1, and you are also making sure that current is, you are also incrementing the current, right? So earlier current is pointing here and current is here now. So closely understand, you are also making sure that current is here. Now if you closely see, when you compare 2 and 3, so 2 is smaller, so that you will add 2 and you move L2 here, and you are also making sure that current is moving here. Okay, now when you compare 3 and 4, 3 is smaller, so that you are adding 3 and you are incrementing current, you are also incrementing L1. Now when you compare 4 and 5, so 4 is smaller, you are adding L2, 4, you are incrementing current and you are also incrementing L2. So when you compare 5 and 6, so you are updating 5, incrementing the current and incrementing L1. So L1 is reaching null, so that you are blindly appending current dot next equal to L2, so which is 6. So not only 6, whatever value you have, it will just append here. So finally you are returning dummy dot next, so which is 1, 2, 3, 4, 5, 6. Is that clear? So what is the space complexity here? What is the space complexity here?
Yeah, it's order of one. We are not creating any new nodes, right?
So which is constant, right? Because we are using the same references and just manipulating the next pointer. That's it. So that's how it works. Uh, can you try this with recursion? Can you try the same code with recursion? Yeah, you give a try for recursion. I think we are already.
Yeah, for today.
For today it is done. Huh?
Yeah.
Okay. Yeah. Please practice these three problems. If you if you solve these three problems, I think you can solve the next problem too. Try solving next problem. I will talk about if you solve these three problems, you can definitely solve next two problems. Give a try. If it works, it's fine. Otherwise, I will teach tomorrow. Okay. But you must and should practice.